we've reached an important part of our course, which is the normal probability distribution. Let's take a look at the big picture. In Chapter 6, we looked at discrete probability distributions. Those dealt with discrete variables. In other words, variables that are mostly whole numbers. Examples were the number of students at a college who are nearsighted, or the number of customers waiting for a table at 6 p.m. And the histograms of these distributions had bars. The bars represented the probabilities for different outcomes. But the normal distribution deals with continuous variables. Continuous variables can have any range of decimal values. They don't have to be only whole numbers. Examples of a continuous variable would be the weights of cookies at a bakery, or the wait time of customers in a restaurant, or the body lengths of grizzly bears in California. Also, a normal distribution is another name for a bell-shaped curve, the same bell-shaped curves that came up in Chapter 3. So one example that is similar to what you'll see on the homework is number 28. They have this normal curve. They're asking for the mean and the standard deviation. And the mean is always going to be in the center, at the peak of that curve. So the mean is 530. And the standard deviation is the amount that you're jumping up every deviation, which is 100. Let's take a look at 7.1, number 32. The lives of refrigerators are normally distributed with a mean of 14 years and a standard deviation of 2.5 years. Draw a normal curve with the parameters labeled. The mean will go in the middle. Every deviation is 2.5, so I'll add and subtract 2.5 going above and below the mean. Part B, shade the region that represents the proportion of refrigerators that last for more than 17 years. The x-axis represents the life of a refrigerator, and 17 would be about here. Here's 17. And the proportion that lasts for more than 17 years would be this whole area that's above 17. So I'm going to just shade that whole section in. So this is part B. Part C, suppose the area under the normal curve to the right of x equals 17 is 0.1151. Provide two interpretations of this result. So the area of that shaded region is 0.1151. One interpretation of the area under a normal curve is interpreting it as a proportion. And you could say something like 11.51% of refrigerators last for more than 17 years. Another way you could interpret the area under a normal curve is that it's a probability. So for that same shaded area, we could interpret that as the probability that the probability that a randomly selected refrigerator lasts more than 17 years is 0.1151. Keep in mind that percentages, proportions, and probabilities all have the same number and meaning. They just have different contexts. Last example, 7.1, number 35. We'll just do part B for now. The lengths of human pregnancies are normally distributed with a mean of 266 days and a standard deviation of 16 days. And this figure represents the normal curve. The mean is 266, and the shaded region is between 230 and 260, and the area of that region is 0.3416. One interpretation of that area would be as a proportion, and you could say something like 34.16% of pregnancies last between 230 and 260 days. The other way that you could interpret that area is as a probability, and you could say something like the probability that a randomly selected pregnancy lasts between 230 and 260 days is 0.3416.